Thanks everyone for joining us tonight for the May General Meeting of the Central Florida Astronomical Society. I'm your president, Frank Kane, and we got a good program for you lined up tonight. But before we get started, if you're watching this and you are not yet a member of CFAS, what are you waiting for? You get all sorts of benefits by doing so. Access to our private events and dark sky viewing locations in Geneva, Florida, to be specific. Got a few more nights scheduled for that we'll talk about after our main speaker. We also have a great loaner telescope program. Contact loaners at cfas.org for more information if you want to try before you buy. Get your hand on some observing hardware and maybe even one of those new fancy C-Star things to see what they're all about for free. We also have a vibrant online community at cfas.groups.io for our members, where we talk about all sorts of astro stuff, and access to our quarterly meetings at the Seminole State Planetarium in Sanford, Florida. Can't imagine a better venue for an astronomy club. You also get Astronomical League membership together with their quarterly publication as part of your membership for free. And remember, we're a nonprofit 501c3 organization, 100% volunteer powered. So every penny of your dues goes toward our mission of spreading the love of astronomy. You also get discounts on Astronomy and Sky and Telescope magazine. And if you're interested in learning more, head on over to cfas.org for information on signing up. Tonight's agenda, we are starting off with our main speaker, Professor Emily Levesque from the University of Washington, out of my old stomping grounds, author of The Last Stargazers, awesome book. We're going to talk about some of the stories in there. After that, got some club news for you, and we'll wrap things up as always with our astrophotography showcase with some of the latest images from our members. So before we get started with our main speaker, just some quick housekeeping. If you do have questions for our speaker, go ahead and throw them in the chat and we'll get to them as we can. Or if you're feeling brave, hit that raise hand icon under the react button at the bottom of your screen. And well, you can go ahead and ask those questions live if you want to as well. So with that, let me introduce our main speaker tonight. Emily Levesque is the astronomy professor at the University of Washington. And she is most recently a 2022 to 2023 Fulbright U.S. Scholar and a 2022 Guggenheim Fellow. She's received the American Astronomical Society's 2023 Chambliss Astronomical Writing Award, the 2020 Newton Lacy Pierce Prize, and the 2014 Annie Jump Cannon Award. She's also a 2019 Cottrell Scholar, a 2018 Kavli Fellow, and a 2017 Alfred P. Sloan Research Fellow. From 2010 to 2015, Levesque was a Hubble and Einstein postdoctoral fellow at the University of Colorado at Boulder, and she received her astronomy PhD at the University of Hawaii in 2010 and her SB in physics from MIT in 2006. Emily's first popular science book, The Last Stargazers, shares the tales and experiences of astronomical observing, and she's also written two academic books, a professional text on red supergiants and a graduate textbook on stellar interiors and evolution, written with co-author Henry J.G.L.M. Lammers. And I hope I didn't mangle anyone's name too badly in that introduction, but please let me introduce Emily Levesque. Thank you so much for joining us tonight.
Hi, thanks so much for inviting me.
Yeah. It's I love having you here. Like, this book is awesome, by the way. Like, I've read this a couple of times now and really enjoy it. So I'm very excited to talk to you about the stories in this book.
Thank you.
Uh, yeah. So, I mean, the title, let's start with that. The Last Stargazers, the enduring story of astronomy's vanishing explorers. It sounds a little bit like a lament of days gone by, but that's really not the tone of the book, right? It's much more upbeat, and it's a lot of funny stories in here, right?
Yeah, it's meant to really be a behind the scenes look at what professional astronomy is like and what it's actually like to do astronomy every day or every night as your job. And where the title came from, I've had a lot of my colleagues ask me about the title. And part of it is that it is marking an era that we're still in right now where technology is really changing how we do astronomy, from backyard astronomy all the way up through like new telescopes that are coming online or being designed. And it means that the stories in the book that I tell are, in some cases, kind of like relics of the way things used to be done. And it's not necessarily a lament saying we should go back to those days, but I was interviewing colleagues and getting these stories down, thinking like somebody should write these down. Somebody should tell the story of what it's like to like gather data on a glass plate or ride in the top of a telescope at prime focus, because we're not going to be doing that again. And it was a really fun era of astronomy. So that's part of what drove the title.
Absolutely. Yeah, and I hope we can talk about some of that for sure. Yeah, that seems like a design flaw, the whole writing at the top of a telescope thing, but we'll get to that in a minute. So let's talk a little bit about your background. How did you get into astronomy? What initially inspired you to get into this field?
So I very literally got into astronomy when I was about two, when I was a really, really little kid. When I was little, was the last time that Halley's Comet made its sort of close flyby of Earth. And I had a much older brother who was supposed to observe the comet for a school project. And I had parents who were, neither of them were scientists or educated in science, but they both really liked science. So we took a little family trip out into the backyard to look at the comet. And according to them, I was like a toddler and just fussy and over it until they pointed me up, at which point I was just and just got fascinated. And from then on, people would ask me what I wanted to be when I grew up. And I would say, well, I'm going to be a ballerina or an astronomer, or I'm going to be a firefighter or an astronomer. And then later on, I'm going to be a violinist or an astronomer. And astronomer just stuck. So it's what I do to this day.
Wow, that's awesome. Like just a spark of interest in your youth and it just kept on blossoming.
Yep.
Yeah, that's how it goes for a lot of us, I think. And I'm curious, like, where your writing experience came from. I mean, you're a really great storyteller, and the writing of this book is pretty awesome, and you've got the awards to show it. But how did that come to be?
I'm glad that you enjoyed it because writing was a much less formal thing that I did. I guess I also wrote when I was really little. I have this rambling story with 5-year-old spelling about a little girl and the adventures she had with her doll that filled a shockingly thick book, self-illustrated, self-published. But I really liked writing the whole time I was growing up, and I loved reading. My mom is a librarian, and she always made sure that I had just like any book I could get my hands on. And as I was moving into sort of professional life, I left creative writing behind, but I had always thought, writing a book would be really fun. And I wrote a textbook, I wrote some professional writing. And then someone asked me at one point, have you ever thought about writing a popular science book? And it was a really funny moment because I said, no, never. And I really hadn't. And then they said, well, if you did write one, what do you think would be a good story? And I said, well, I guess. And then the idea for the Last Stargazers came out of my mouth because it came out of all the storytelling that my colleagues and I do. And I got to, at that point, sort of go back and capitalize on the fact that I just liked writing. I studied writing when I was in like K through 12 and in college, and really just got to sort of see how well I could do with it on my own. And apparently it went well. So it was a lot of fun.
Yeah, that's awesome. I mean, that intersection of, writing talent and astronomy is not a common thing, I don't think. So it's a very powerful tool for, outreach, if you will, and getting people excited about astronomy outside of the academic world. So
Yeah.
thank you. So yeah, let's dive into some of the stories in this book. I mean, some of them are just like absolutely, well, bizarre is the only word I can come up with it. Like, there's that story of the McDonald Observatory in Texas that has like gunshot wounds on it, right? You want to walk us through
Yes.
that one?
Yes, I'm going to show a couple pictures for this one too.
Yeah.
I absolutely can't tell the story without them because it's just wild. And part of the backstory for why this is in the book is because I interviewed more than 100 of my colleagues for the book. I wanted to put my own observing experiences in. I wanted to talk to people who were brand new observers who'd been observing for decades. And I mostly just kind of let them talk and tell me stories. But I asked everybody, what is your favorite, like, third hand half true tall tale story that you like got told over beers at a conference that you only sort of remember? Like, what story is just infamous in the field and has to be in the book? And by a huge margin, the most common answer that I got from people was, do you have the one about the telescope that got shot? And everybody half remembered this story. It was a telescope somewhere. They all remembered that it was in Texas, but everybody was like, oh, there was this telescope, and I don't know, there were, spurned lovers fighting at the telescope, or there was a like student who hated their advisor, and they just imagined all sorts of dramatic lead ups that came down to like a shootout at a telescope. The reality was none of these things, but it's still a wild story. This happened shortly after the telescope in the picture, which is the McDonald Observatory 107-inch, had been constructed. It was brand new, it was beautiful, it was a big telescope at the time. And unfortunately, the story behind how a gun got involved in the story is that there was a employee at the observatory who was undergoing a mental health crisis, and he became, for whatever reason, hell-bent on destroying the 107-inch telescope. So he showed up at the telescope brandishing a handgun, and he pointed it at the telescope operator at first, because even then there were people who were specially trained to direct telescopes, and then astronomers who would sort of decide where they went. So he pointed it at the operator. Fortunately, no one was injured in the story, and he demanded that the operator lower the telescope so that you could see all the way down the barrel to this beautiful new primary mirror.
Mm.
And then he emptied the clip of the gun into the mirror. And I think he was hoping for a like dramatic shattering. And these mirrors are about a foot and a half thick, and they're made of borosilicate glass. They're made of basically Pyrex. So you shoot a bullet into that, and it just kind of goes and it lands like a dart in a dartboard. So he was underwhelmed. This is what happened. He then tried to, go after it with a hammer instead, at which point he was subdued. He was led away, but the police were called to the scene. And this meant that the sheriff drove out to the observatory and rode up, and he looked down the barrel at this, what you see here, and he went, "Oh my God, the telescope's been destroyed," because he didn't know what a Cassegrain focus was. And he thought that the big hole in the middle was, he must have thought he was shooting a bazooka, but he thought the big hole in the middle was the result
Oh,
of the problem. And instead, it was just these little bullet holes that the observatory staff looked at, and they said, "Well, that's not really that bad. We can dig the bullets out. We'll paint over the holes so that there isn't shattered glass sort of pointing light in random directions. And it's really kind of like the 107-inch just became the 106-inch. Like we lost a little collecting area, but it'll be fine." And they kept observing with it. And the story did get out into the astronomy community. People were freaked out because they thought the mirror had been more damaged. And Harlan Smith, who was the director of the observatory at the time, got to put out this amazing bulletin in a astronomy periodical that normally announced like, "Hey, there's a new nova in so and so cluster." And he had to put out this announcement saying, "Yes, this happened, but don't worry, the harm from the bullets was extraordinarily small. We're still observing. We took lovely data last night." And like, the harm from the bullets was extraordinarily small is not a thing that usually shows up in scientific literature. So it was easily the most memorable story that people told some version of to me. And it was really interesting to try and hunt down the true tale of what had happened.
wow. Yeah, that's not a sentence you hear very often. Uh,
Oh,
good. Yeah. Good reminder to our amateur astronomers here in the club too. Don't get too upset about those dust motes on your primary mirror. They don't really matter that much. If, bullet holes are okay, then so is dust. That's awesome.
they still take the mirror down and re-illuminize it regularly. And every time they do, the bullet holes are still there. They've, fully carved out little holes for them now. But yeah,
But they're very clean bullet holes. Yes.
very clean, very nicely coated in aluminum bullet holes.
Awesome. Wow. Yeah, and the other story that really stuck out to me in this book was the story from the Lick Observatory, where we had kind of this slow motion chase scene, if you will, and you can tell it a lot better than I can. So walk us through that
Yeah.
one,
So,
please.
so I love telling people this story because it also gets at what it used to be like to observe at telescopes back in the days before we had um, any kind of digital imaging. So this gets back to the era when you would use photographic plates. And these were incredibly lovingly prepared glass plates. They were specially treated on one side with a chemical emulsion that would darken when it was exposed to light. Astronomers would mass order these from like Kodak, and they would get crates of plates, and they would then do everything they possibly could to them to make them as sensitive to light as possible, like even more than what Kodak would typically do. So they would expose them to extreme temperatures. They'd like bake them or freeze them. They would bathe them in ammonia. I knew a guy who swore he could rub lemon juice on a plate and improve it. They would slice these plates to exactly the size you can see here that would fit into the telescope's camera. And then when they would sit next to the telescope's camera all night, painstakingly loading plates in and taking them out. They're doing all this work, by the way, in the dark, because if you expose the plate to light, even briefly, it will saturate and you'll lose whatever image you have on there. So this was already painstaking enough, and it got very complicated when you remember where astronomers would often sit, because they'd be sitting at the camera, which was often placed at the telescope's prime focus, which meant that this is a great picture of one example where you have an astronomer sitting at the prime focus of, this is the Palomar 200-inch. And it's hard to tell because it's pointed relatively low, but he's, far, far above that primary mirror. He would normally be, riding around the top of the dome. As a fun side note, the astronomer in this picture is actually Edwin Hubble,
Hmm.
posing with the 200-inch shortly after it was built. But so astronomers would just sit up there all night, sort of shivering through these long, cold nights, loading plates in and out and exposing plates, sometimes for hours or even the whole night. Because they were sitting up there, they had the telescope operators or night assistants that would help them. The astronomers could turn the telescope back and forth to point to where they wanted to go. but night assistants would be in charge of running everything else. They would, help with the dome spin to stay aligned with the telescope. They could help the astronomer get over to a little ladder or elevator on the side of the dome so that they could climb up and down and get in and out of the telescope. And this led to a really fun incident at Lick Observatory in California with an astronomer who, after a discussion with an editor, we anonymized him in the book because it's not the most flattering story of him. But he was sitting in the foreground of this photo at the top of that telescope that you see open, at the top of Lick's biggest telescope. And he had been perched up there pretty silently. He was apparently not normally a man of many words. He'd been sitting there all night exposing one glass plate on this faint galaxy for just hours and hours and hours. And his night assistant was kind of going in to check on him, going, he hasn't said anything. I'm not sure if he needs a break. I'm not sure how things are going. Let me wander into the dome and see how he's doing. And as the night assistant walked into the dome, his jacket sleeve caught the light switch in the dome. So the lights in the dome come flooding on. All this light goes pouring onto the plate. It immediately ruins it. And this quiet astronomer suddenly just howls in fury from the top of the telescope. And he starts just cursing the name of the night assistant. And he's shouting down, going, "You've ruined all this hard work. My whole night is, I'm going to get down from this telescope and kill you." And then starts trying to slowly turn the telescope over to the part of the dome where the ladder is mounted. And the night assistant was incredibly surprised at how angry he was and went, "He might really kill me. I maybe shouldn't let him down." So since the night assistant could control the dome with the ladder attached to it, the astronomer sort of slowly moving toward the ladder, and then the ladder starts spinning away from him as the night assistant is going, "Yeah, I'm not letting you down until you calm down." And it just turned into this like little slow motion game of chase, and the night assistant's swearing murder, and the guy on the ground is going, "I'm not letting you down until you calm down." And I always like imagining the other people on the mountain looking out at the telescope in the middle of this perfect night, and like the lights are on and the dome's doing this, going, "What are they doing?" But it was one of the more dramatic examples of how quickly you could lose an entire night's worth of work or an entire night's worth of data just from a small mistake. And yeah, one of the goofier incidents that's happened at a telescope.
That's incredible. I hope the night assistant survived the encounter. Hopefully he calmed down before he got back down.
Either that or he's still the astronomer's still up there. It's going to be one of the two.
They're still spinning around to this day. Yeah.
No. Yeah.
Gosh. That's crazy that people would sit up there. I mean, that doesn't seem safe. I mean, like you think they'd have like some sort of safety harness or something at least up there, but no.
Safety apparently varied very wildly from telescope to telescope. And I talked to people who described climbing up these like rickety old ladders or taking elevators that barely deserved the name up. One woman told me about how you would take an elevator up, but then walk along this catwalk to get into the telescope. And you do it in the dark. And all you're thinking about is, well, I've got my plates. I've got this plan to observe. This is fine. And then apparently she did this for her first night of observing, saw the catwalk in the daytime, and it's like, "I'm never doing that again. You're going to find another way to get me into this telescope." It was also often freezing up there because you want the air above a telescope to be nice and cold. So astronomers would do things like, put on little heated World War II flight suits and like bring a battery up with them. Or if they were at the Cassegrain focus, they would plug themselves into the wall to kind of stay as warm as they possibly could. And sometimes you were just cold. Yeah.
Yeah. It's hard to imagine, these days. Well, we're getting there, but these days you can just do it all remotely from, your office at home, and it's so different. But
yeah,
you had to work for it back then, I guess, a little bit more.
You earned every photon. Yeah.
Absolutely. Yep. Cool. Yeah, we're just kind of like going through some of the stories in the book, and there's a lot more depth and details of these stories in the book. So, y'all should get a copy. It's awesome. Another one, you spent some time with Sophia. You got a whole chapter on that. That's the telescope on a plane kind of thing. And actually, one of our members was out there as well a couple of years ago. I think she's on right now. Sharifa, I think, was out there.
I hope she got the chance to fly on it. Even touring it is fascinating.
Yeah. But you had a rather unique experience on it, didn't you?
I did. Well, somebody just posted, don't tell all the stories. I just bought it. And these are absolutely not all the stories, but I do always love showing a picture of Sophia and just sort of explaining what it is. So Sophia stands for the Stratospheric Observatory for Infrared Astronomy. And this was a NASA operated observatory It was the latest in a string of airborne observatories, which people barely know about. And I really got to enjoy spending a whole chapter going into the history of putting telescopes aloft in creative ways on airplanes, on balloons, on suborbital rockets. But Sophia has sort of been the latest crown jewel in this technique. And it is a specially modified Boeing 747 that flies up higher than traditional commercial aircraft. It flies up to the mid to high 400,000 feet range. And while it is flying, it opens that back door that you see in the rear of the plane, and it exposes a about 2.5 meter infrared telescope. And there's great reason for this. Infrared light bounces off of water vapor. So from the ground, we only get a little bit of the infrared spectrum and we lose a lot of the signal. But if you can get even up into the stratosphere, you're above 99% of the water vapor in Earth's atmosphere, and you get a lot of the advantages of observing in space without all the expense of launching a space telescope. So I had heard from a college professor about using Sophia's predecessor, and I badly wanted to learn about what airborne astronomy was like. So I went out and got a tour of Sophia. I was supposed to fly along on one of Sophia's missions. We ran into some weather problems. When you think about it, Sophia has all the problems of every airline you've ever flown on and all the problems of any observatory you've ever dealt with. But I was able to eventually successfully fly on it. I actually got time as a researcher to gather my own data on it and was able to go back and fly as a scientist, not as a journalist. We, at the time that I went, flew out of Christchurch, New Zealand, while it was observing in the southern hemisphere during our summer, their winter. It was really cool to actually like fly on board the plane, and I got to go through all sorts of special safety training. I remember sitting on the plane when the door opened, and you absolutely cannot even tell. I asked the pilots what that was like, and they said that they couldn't tell except by an indicator light when the door opened or closed because it was so beautifully designed. We actually flew far enough south on that trip that we saw the aurora out the window of the plane, and that was the first time I'd ever seen northern or southern lights. And it is to this day the coolest adventure I've ever gotten to have as an astronomer, and I've gotten to do some pretty cool stuff. This was beyond belief, so that was a lot of fun.
That's awesome. Yeah, it's great to see the pictures of this, to sort of like solidify what you're describing in the book too, because I can't imagine what that was like. Like you're flying in Sophia. How cool is that, right? And now they're going to turn off the lights in the cabin so you can see the southern lights. I mean, what an
So
experience.
I actually talk about this in the book because my professor in undergrad had described flying on Sophia's predecessor, and all he said was, there's a telescope that observes out the back of a plane. And at 18, I had pretty much never been on a plane, and I was still sort of figuring out what professional astronomy was. And my version of a telescope in my head was like the little 10-inch that we had in my backyard. So I was picturing astronomers like holding on to something real tight and pointing a little telescope out the back and just sort of like windswept. And in reality, it's in a sealed chamber. You can see the back of the telescope as you fly, which is actually fascinating too, because it's suspended on, fun fact for parties, the world's largest ball bearing. So as the plane experiences turbulence, the telescope is held perfectly still. And your view of that from inside is that you see all the telescope instrumentation sort of bumping and floating around as you move. But in reality, it's the thing that's staying perfectly steady.
Yeah, you're bumping around. That blows my
Yeah.
mind. I mean, like we go to like extreme measures to make sure that telescopes are on a very solid, unmoving platform on Earth. And the entire idea of putting it on a plane just seems crazy, but it works.
It works amazingly well. Yeah.
Yeah, it's a miracle of engineering, really.
Yeah.
That's cool. And there's another fun story in the book, so not to give it away, but it had a bad day once. Let's just put it that way, and chaos ensued. So I'll let you read the book to learn more about that story. Cool. What happened?
Which many telescopes have had a bad day. I'm wondering about how chaotic we're talking.
Oh, that's the one where it broke loose, right? So, but
Um, are you talking about the telescope in West Virginia?
am I? I thought it was. It's been a year since I read this book, but I thought there was a story of Sophia actually like bouncing around a little bit inside there. Maybe it was just the turbulence that you were talking about. Come to think of it.
It might have just been the turbulence. There were so predecessor telescopes did. There were unfortunately a couple of crashes involving early airborne telescopes. And I think the one you might be thinking of is actually, I don't have a picture of this, but it's a story that, as it happens, happened to a colleague of mine at the University of Washington. He was launching a science payload to observe on a scientific balloon. And he was observing down in Australia. They had a very heavy payload with like gamma ray instruments and all sorts of stuff. And they had launched this payload a couple times before very successfully. And he still laughs about this. He invited the press out to watch because there was going to be this perfect, beautiful balloon launch to send all these scientific instruments high into the atmosphere. And some things went wrong during the launch, and the payload actually got broken off of the balloon and went on this like destructive tumble. It went blowing through like a protective gate at the launch area. It nearly hit someone's car. And there's this sad video footage of the Australian news saying, well, this didn't go as planned, but we're still here reporting on it. And in the back, you can see the team like picking up pieces of the instrument and trying to figure out what to do. But I'm glad that you asked the question the way that you did, though, because it's telling that you said, oh, there was a time when things went terribly wrong for a telescope. And my immediate reaction was, which one?
Which one?
Because
Yes, there are so many to choose from.
and
Yeah.
there's such complicated instruments that things can go terribly wrong when something tiny happens, let alone when there's stories in the book of, the telescope that got shot. There's telescopes that have ridden out volcanoes that have catastrophically collapsed. There's all sorts of incredible things that happen. And when you think about it that way, it's amazing that we're able to do as much astronomy as we do. But
Absolutely.
normally they work absolutely to perfection, which is lovely.
Yep. Yeah. Whatever happened to Sophia? Is it still around, or did they end up shutting that down?
It is not. Sophia unfortunately got shut down. Sophia got shut down a couple of years ago. It was part of the casualties of NASA's flat budget.
Hmm.
And we're obviously getting ready to deal with more problems with that, which I can talk about more a bit later. But Sophia was expensive to operate. It is not as expensive as a space telescope, but it requires a full aircraft crew, it requires a full science crew. There are engineering crews for every instrument that it operates. And it was an astonishing instrument because you were essentially simulating the advantages of space observing at a fraction of the cost, but it's still a lot more expensive than just a telescope that's sitting on the ground. So NASA pulled support for it. The plane itself, though, someone put it in the chat. The
Yeah.
plane itself is at the Pima Air Museum in Tucson, which is fabulous. I'm really glad that it is on display for people to admire. I'll admit, being in Seattle, I was a little sorry that Boeing didn't jump at the chance to put it in Boeing's museum, but it's going to be very well appreciated in Tucson because of the huge astronomy community that's there. So it's a
For
shame it's
sure.
not flying anymore, but I'm really glad that I got to see it while it was.
Well, it's still inspiring people in Tucson, and at least it's not just sitting, in a desert in Palmdale, exposed to the elements like so many other things are there.
So
Cool.
when we observed it, we saw another 747 that was just sort of sitting exposed to the elements in Palmdale. And apparently I think it might have been an old Air Force One. It might have been no, I think it was the old 747 that used to carry the shuttle. And they
Yes.
joked that they would sort of cannibalize it for parts. They were like, well, that emergency slide is compatible with our emergency slide. Let's go get it. So there was a bit of a market going around in old 747 SP parts. So at
Hmm.
least at least Sophia is now somewhere that people can enjoy it.
Yes, it's a much better fate.
Yeah.
Cool. And also in Washington, you got LIGO, at least one of the locations there out in Eastern Washington. We had a speaker
Yes.
on about a year ago, Shane Larson, who's involved in that program as well. Um,
Yeah.
oh, you know him? That's cool.
I know of him. I know his
Yeah.
name. Yeah.
Oh, yeah. Well, small world. But yeah, tell us about the
Astronomy is
experience
very
of.
small.
Yeah, true
Yeah.
enough. But yeah, tell us about your experience like visiting LIGO and what's going on there and what gravitational waves are all about.
Yeah, I can actually show a slide that I like using just to demonstrate what gravitational waves are, but I can describe the observatory a little bit first. So there's two LIGO locations in the United States. There's one out in Eastern Washington and there's one in Louisiana. And they're both based around the same very simple but very incredible design. And what they are these two arms that are 2 kilometers no, sorry, they're 4 kilometers in length, so a little more than 2.2 miles, I think, from end to end. And these are two vacuum tube arms that are built perfectly, exactly, astonishingly straight. They take the curvature of the Earth into account. They are absolutely perfectly straight. And hanging at the ends and at interim points along these arms are what they call test masses, and they're mirrors that can reflect back lasers. So at the center building that you see connecting these two arms of the observatory, they have an infrared laser that they will fire down and back along the arms. And the laser will fly all the way to the end. It will bounce off the test mass and it will arrive back at the main building. And assuming things are normal and assuming there's no gravitational wave and there's nothing else perturbing the observatory, which we'll come back to, the lasers just sort of travel down to the end. They bounce off the end, they come back at the same time, and they're sort of wave functions. Their light annihilates itself perfectly, and there's no signal, there's no gravitational wave. So what gravitational waves are their density waves in the fabric of space-time. And a lot of times when you see them illustrated, they kind of look like ripples on a pond, like if you drop a pebble into a pond. And I like thinking of them a little more as slinky waves. If you were to hold a slinky in your hands, you can make a wave by sort of picking up one hand or the other and watching a wave travel up and down. Or you could do this, like you're playing an accordion. And you could send a little density wave just sort of going from one end of the slinky to the other. And that's what a gravitational wave is, except with space-time. So it sends this little density wave traveling through space-time and everything in it, including the Earth. So when that happens, the Earth will get a little squeezed and then a little stretched as the wave goes by. And if you have two perfect arms that are exactly at right angles to another, and a gravitational wave passes through this instrument, one arm will get squeezed and one arm will get stretched. So they're no longer quite the same length. And now when you fire those lasers, the lasers will arrive back at the building at very slightly different times because one has taken a slightly shorter trip than the other. And this is detected as a gravitational wave. The engineering of LIGO, I mean, this took decades to build. I think that this and the moon landing are the two most astonishing things we've ever built, because LIGO successfully detected gravitational waves 10 years ago now in 2015. It's wild that it has been a decade since that's happened. We now have pedestrian, practically, catalogs of gravitational waves that we've detected. But the big challenge for them for a long time was not that they couldn't detect gravitational waves, it was they detected everything else. So they would detect footsteps, they would detect rain, they would detect trucks driving by on a highway, where this is out in eastern Washington state. The detector could tell when waves were hitting the shore on the other side of the state.
Whoa.
I got to visit on a Tuesday, which is when they closed down for engineering purposes, which meant that I could actually walk around on the site. Normally it's very closed. And that day there had been an earthquake in Papua New Guinea, like 17 hours earlier. And you could still see on the data sort of the ringing signal of this earthquake traversing the planet and, getting picked up. So it was beyond incredible how precisely they had built this machine. It's to the point where those giant mirrors hang from glass threads instead of wires, because the atomic motion in glass is smaller than the atomic motion in a metal wire. And that was enough to perturb the test masses. Like, physics geeks can just absolutely go down a rabbit hole on this. So they're able to plan for a lot of things like earthquakes, trucks, waves, rain, atomic motion. And I do love the things that occasionally catch them by surprise. And every telescope has some version of accidentally detecting something. My favorite one here was that in Hanford, Washington in the summer, they're in the middle of the desert. It's very hot. They have to keep the vacuum tubes cool, and they have cooling lines that run to the observatory that accumulate ice. And there was a raven that decided that this would make a really excellent place to stop on a hot day and get a drink. So they were getting these weird little signals and going, what in the world is this? It's not, black holes, we're pretty sure, but what are we detecting? And someone eventually noticed these little peck marks and then spotted the raven in action. The whole place is run like a beautiful, like many, many thousands of people engineering operation. So they submit a ticket for the raven, and then they figure out what is going on with the peck marks. They sent a grad student out to mimic a raven and test the hypothesis and just sort of hit at the ice with a hammer. And they realized that this was what they're detecting. But I love that, as careful as they are about, every tiny thing that could mess with the LIGO signal, occasionally a bird can still surprise them and mess things up.
Thirsty the Raven. Good name.
Thirsty the Raven.
Gosh.
Yep.
Yep. That's amazing. I can't even imagine how they control for all those sources of interference. That's amazing in its own right. My gosh. And another cool story is like the how they kind of like tested themselves using these blind injections, right? Like they would actually like very secretively like you put in a fake signal and see if people could figure it out. Is that the idea?
Yeah, and they did this for a couple of reasons. So LIGO for years would inject a fake signal into their data um, to first of all make sure that they were capable of detecting the teeny tiny compression and stretch of a gravitational wave. And it also served as an interesting way to test their team. They wanted to test that when something was detected, it was properly tested, properly reproduced, properly evaluated. People would actually go as far as practicing writing up a paper and analyzing the data. And it turned into a secrecy test of the community as well,
Mhm.
because if you've detected gravitational waves for the first time, it's a stunning news story. It's one of the biggest science discoveries of the past decade. It earned a Nobel Prize, and you don't want that news leaking early. So it was an interesting little test of we're not going to leak, right? Everybody's going to keep this a secret because you don't know if this is real or not. It would actually get up to a final stage where I think in the early days they would open an envelope and it would say like real or fake, and then eventually it was a slide that they would project. And it worked amazingly to test the group. And then it turned into a great psychological tool because everybody was well aware that something could be real or fake. If somebody was bad at keeping a secret, then even the rest of the community knew, well, this could be real or this could be fake. And I remember going to a conference in late 2015, and we were in a session that was essentially titled, "What if gravitational waves were real?" We hadn't announced a discovery yet. And a group of gravitational wave people came and they did their very best poker faces, but just said,
Mhm.
we're going to sit here and not say anything. And none of us were remotely interested because we thought, well, they're kind of acting like they found one, but they don't know. It could be fake. And turns out that time it was real, but it
Mhm.
just turned into sort of layers of secrecy and insurance that ensured that when it actually happened, it was very well evaluated, very well tested, and a very well kept secret right up until it was announced.
Yeah. And the great story there, of course, is that they detected one like as soon as they turned it on, which is just incredible, but
Yeah.
good
So
story.
they detected one as soon as they turned it on, and I think three people knew this, but they actually turned it on before they had the fake testing system up and running. They turned
Mhm.
the detector on, and then they were going to turn the fake testing system on, or they were fixing it, and it was going to come on a couple days later. And they detected something, and I think three people went, "It has to be real because we know that this isn't running yet." So it backfired a little bit at the very end, but
Mhm.
it was fascinating. Yeah.
Yeah, definitely one of the biggest, accomplishments of our age for sure. And now we're putting one in space, right? The LISA array, is it? I think that's
Yes. I'm trying laser interferometry for
interferometer.
an interferometer for space astronomy or something like that. I don't
Sounds
remember
right.
the exact acronym,
Yeah.
but yeah, so LISA is going to be stunning. I think it's three L-shaped detectors, and I think each arm of the detector is 1 million kilometers, and it's going to be sort of orbiting the sun behind. It's sort of in a trailing orbit behind the Earth. They've
Right.
done some feasibility testing for it, and it's stunning. But the bigger and more sensitive the detector is, the different frequencies of gravitational waves you can detect. So for something like that, we'll really be getting literally a new view, or I guess a new sound is the way that we think of it, of the
Hmm.
universe.
Absolutely. Cool. All right, folks, we'll be opening things up to questions in about 10 minutes or so. So feel free to pile on in the chat there. Or again, if you want to raise your hand from the React button, you can ask them live if you're feeling brave. But I've got a few more things to ask you here myself. So let's talk about lightning. We're in the lightning capital of America here in Central Florida. And my own observatory has been struck by lightning, by the way. Toasted one of my boards of my mount. But you got some good lightning stories in the book as well. There was one about the monastery at Mount Wilson being struck, Kitt Peak, Mount Hawkins. This is a common problem, right?
Yeah, I mean, I think it's a risk. I actually did not know that Central Florida was the lightning capital of the world. But a difficulty with observatories is even if you're in somewhere that has fewer lightning strikes, you're usually the tallest thing around and you're usually in the middle of nowhere. So it is very easy to put yourself in a position where it's easy to be struck by lightning. And I talked to everyone from folks who were sitting in domes when the domes got struck by lightning. They are designed to handle it. They'll put a lightning rod on top, but I think I remember one guy saying it sounded like the world was ending because it's just the loudest crash you've ever heard in your life. To people that have dealt with fires that have been started by lightning strikes, especially in some of the desert observatories, there is a story in the book of an astronomer who was struck by lightning.
Right.
while working at an observatory. Unfortunately, he was okay. I think I do not remember the exact quote. You'll have to read the book, but he described sort of intentionally behaving slightly oddly after the lightning strike to see if it, raised any of his colleagues' antennae. But yeah, it's one of the many odd realities of where we build telescopes and what happens when you build the telescope in the most remote place you can find on the highest mountain you can find. People talked about dealing with altitude, dealing with all manner of critters and animals that they run into at these observatories. And these are also unbelievably beautiful locations where it's a real privilege to be able to work, but
Mhm.
they come with their quirks.
Yep. I mean, at least people aren't riding around at the top of these things anymore, waiting to get struck. So there's been some progress there, at least a little bit safer
Yes.
these days. Cool.
Mhm.
We got some good questions coming in, so I think I'm just gonna like do one more, and then we'll go on over to Q&A if that's okay. Um, let's see. They already asked you that one, so I'm gonna save that for Q&A. Yeah, let's talk about you kind of mentioned this earlier, kind of the current threats to astronomy and like the state of the world and the astronomy research community. I mean, things have changed, both for the better and for the worse in some respects. We have a lot more light pollution these days. We have more satellites zipping around. What's your take on our biggest challenges right now and what we need to do to kind of like keep astronomy moving forward?
So there's actually been some progress on things like light pollution, which is great. I have colleagues that work with dark sky organizations that try to help places become dark sky cities. There's a great perk in that, and that it is energy efficient as well as being better for the sky. Satellite constellations are more complicated just because they are not very well regulated, and they pose a deeper threat to especially the kind of astronomy that we're really starting to do longer term now. So things like survey astronomy. That there's a telescope that's coming online in Chile. Literally right now, I've been getting messages from colleagues saying we're taking pictures and it's amazing. And this is the Vera Rubin Observatory in Chile, and they are effectively taking a night movie of the night sky. And every time a satellite constellation passes through, it looks like a cat has clawed the frame of the movie. And people will ask, can't you just put that back? Can't you just fix it with AI or Photoshop it back on? And you can, assuming there's nothing behind claw marks. If that is where a supernova happened, if that is where a variable star was, if that is where a near Earth asteroid happened to be spotted, you've lost it forever. So there are astronomers working on how to mitigate the effects of satellite constellations. They're making good progress. It's hard because it gets into regulatory policy, but it's at least a thing we're doing. By a mile, the biggest concern that we're dealing with right now is a relatively recent one, but it's the just heartbreaking state of science funding right now. We do not have an official budget for, it'll be fiscal year 2026, but the proposed budget is horrifying. It cuts NASA's budget for astrophysics research by 68%. It cuts the National Science Foundation as a whole by 55%. I don't believe we know the details of that yet, but we don't expect that that will be evenly applied across NSF divisions. And a worry is that astronomy will be disproportionately hit. It's already very competitive and very challenging to get funding in astronomy. And if entire grants disappear, if the ability to get a grant is cut in half or in a third, it effectively cuts the workforce in half or in a third. And where we really worry is for our young astronomers. Graduate students are supported by advisors with grants. And if you can't get a grant, you can't support a graduate student. And we are looking at realities of things like we may not be able to admit at the University of Washington, we may not be able to admit PhD students next year because the funding situation is so precarious. And we are far from alone. There are research experience programs that are getting canceled. So students that get their first taste of astronomy research and then go on to grad school. I open the book with a story from me doing one of those programs. Those programs are very quickly disappearing as grants get sort of unpredictably canceled or as funding gets cut. And people are very, very, I think someone described this as an extinction level event for astronomy. And they were an asteroid scientist, so they know what they're talking about when they say extinction level event.
Mhm.
It's going to become nearly impossible to keep supporting and keep doing astronomy. And it's a shame because we've launched Webb. We have Hubble. These are telescopes that are going to keep working and going to keep observing. We all have colleagues we adore, and other countries that are going to keep doing this research. And we're glad someone's doing it, but we're going to be incredibly limited in our ability to do it. And eventually we'll be limited on our ability to support the telescopes too. So there's like, I can tell you, for example, people are really worried about what might happen to Hubble. And Hubble's in fabulous shape. Hubble takes groundbreaking new observations every day. It's 30 years old. It's been an amazing investment. And we're worried about whether we can keep it turned on. So it's a very weird time to be looking at what's next for astronomy right now.
Yeah, I definitely wanted to touch on that because a lot of people don't know what's going on there and just how dependent astronomy is on federal funding right now. So,
People ask too if we are able to get private funding. And I've done some of my research with private funding from places like the Sloan Foundation or the Guggenheim Foundation. And it just doesn't work at scale, is the problem. That I got funding from the Sloan Foundation, which was lovely and helped me pay for part of one graduate student's first year. And the scale that you need to do this sort of research, and especially to build telescopes, to launch telescopes, it's beyond what any private funding can do. Even a very successful private business won't necessarily invest in pure research because their job is to serve their shareholders first. So you need a government entity, you need something like the NSF to do science.
yep, yep. Yeah, and if you want to help, I know the Planetary Society is mobilizing a pretty big effort to try to
Yes.
save this.
Mhm.
So go join those fine folks if you can.
They have been
Cool.
fabulous at trying to marshal efforts to advocate for this. So absolutely.
Absolutely.
Yeah.
All right, let's switch gears to some Q&A here. We got some great questions coming in. So let's start with Luke Corwin. When astronomers, I think you mentioned this in the book, how do they go to the bathroom up there at the top of a telescope?
It's a great question, and people do wonder about this. So water bottle. Sometimes you would get down. A lot of times, I think people would just sort of hang out up there. And apparently, the risk was if you brought up a thermos of dinner and an empty thermos, like you had to be extraordinarily good with your labels. But that was the plan for a very long time. I believe that there were some complaints when more women were starting to observe, going, "Look, this might get a little more complicated."
Hmm.
But sadly enough, that era was happening in the 1950s, 1960s, when observing was at least starting to move away from the prime focus to the Cassegrain focus. We wanted focal lengths to get longer. It meant that you could observe from nearby in a warm room, and it made it a little easier. But in the time when people were strapped to the prime focus, you brought up what vessel you could.
Yeah, and that kind of like touches on another topic in the book as well. And this is kind of like, the role of women evolving in astronomy. Like back in the day, the bunker, well, the barracks, dormitories, that's the word I'm looking for. And Mount Wilson was like all men, and there was no women's bathroom, right? So, uh,
Yes. There was a bathroom that did not have a gender assigned to it, and there was the room was known or the dorm was known as the monastery. And what I also actually find funny about this is when I was researching the book, women were observing at these telescopes way before they were allowed to.
mhm.
There was a woman who would observe as her husband's assistant, and her husband did not know which end of a telescope to look through. He was a brilliant astronomer, but he was a theorist, and she was just showing up and running the telescope every night. And she couldn't stay in the monastery, so she was staying in this, freezing, unheated cabin because she absolutely couldn't stay in the same building as the men. And what it really meant was that just the women who were doing astronomy research at the time and who were doing brilliant astronomy research just had all these extra hoops that they had to jump into that were getting in the way of them doing their science. And it's amazing that they were able to do the research that they did. Vera Rubin is an incredible example of this. She has a telescope named after her now and did Nobel Prize level research and also managed to, deal with all this ridiculous red tape so that now it's much easier for women to observe and for anyone to observe. It's nice to see the unnecessary barriers coming down.
Yeah, I'm glad things are going in the right direction
Yeah.
for the most part.
Mhm.
Great question here from William Castro. In your book, The Last of the Stargazers, you mentioned Thorn Zeitko objects. Did I say that right? Zitko? Zeitko?
Thorn Zhitkov object. I had to
Zhitkov. All
ask
right.
Anna Zhitkov how to say her last name, but yes,
Oh my gosh, I was completely off base with that. But
it's
specifically
tough.
HV 2112. So yeah, talk a little bit more about them. And are there any updates or more candidates out there?
Absolutely. And somebody else asked, John asked, can you tell us a bit more about your current research? Which is
Mhm.
perfect because the answers are the
Yes.
same. I'm working on Thorne-Shitgov objects. I actually have right now a grant from the National Science Foundation supporting a graduate student who's working on these. So I will share slides again because these are way too fun. not to show pictures of. So Thorne-Jitgov objects get at one of my research specialties. One of my main specialties is very massive stars before they die and before they undergo core collapse, before they produce a supernova and leave behind a neutron star or a black hole. And my research that I talk about at the opening of the book and that I've worked on ever since is red supergiants. Thorne-Jitgov objects from the outside look just like normal red supergiants, but they have neutron stars for cores. So instead of cores that are undergoing helium fusion and supporting the star against its own collapse, kind of like pretty much every star you see in the sky, they have neutron degenerate cores that are supported by principles of quantum physics. And we think that these cores come from companion stars that died, underwent a supernova, and left behind this dense husk of neutrons that then merged with the main star. Somebody actually made me a beautiful animation of one way that we think stars like this could form. And the way it works is that you start off with these two massive stars in a binary. The more massive star burns through its fuel faster, it dies first. It collapses as a supernova. I love this animation because they give you a camera shake when the explosion goes by, and that produces a neutron star. The companion star that's still alive will then cool off, puff up, become a red supergiant, and swallow that neutron star. And that then becomes what we see externally as a Thorne-Jitgov object. It looks just like a red supergiant, but it has this neutron star core. And so far, we are very actively working on this. I had like meetings about this today. We are trying to figure out how we can possibly tell the difference between a normal red supergiant, a weird red supergiant, and one of these. The best solution that we have so far is the chemical signature of the star, because putting a neutron star the base of all those outer layers of gas means that you can host all sorts of weird chemical processes, and you wind up with a huge excess of like molybdenum or rubidium, these very unexpected elements that show up in huge quantities in a Thorne-Jitgov object but aren't anywhere to be found in a regular red supergiant. Getting observations of that, though, is really tough because you need a very high resolution spectrum of the star. You're getting the light, you're sorting it out according to color very, very precisely, and you're looking at a specific tiny wavelength of light that's absorbed by molybdenum and trying to see, normal red supergiant A and potential Thorne-Jitgov object B and comparing just how much light is being absorbed. It's really fiddly observing. So at the end of the book, I talk about the first time we went and searched for these. And we actually wound up finding a candidate that let us test different formation theories. I'll come back to this slide in a minute. But we wound up at Las Campanas Observatory in Chile, taking very high resolution observations of red supergiants. And people imagine what our data looks like when it comes in, and amateur astronomers know this. You think the finished image is going to look like this, and our data looked like this when it was coming in. It was these ugly spectra, just sort of line by line, trying to look at different pieces of the spectrum. But one of my colleagues, who is so experienced with this data that she can instantly read it, looked at this and immediately spotted those little bright points. And she said, I don't know what that is, but I know that I like it. At the time, we were watching a bunch of stars that we were observing sort of flash past on the screen and kind of went, oh, that one's cool, and then never thought about it again. And it turned out that was our Thorne-Jitgov object candidate, because those were glowing hydrogen atoms excited by pulsations in the star's atmosphere. The atmosphere of a star like this is unstable enough, because the neutron star is in there at the core, that you actually wind up exciting emission from some of these atoms, in addition to the excess rubidium, the excess molybdenum that we wound up finding. So we found one star that we published in 2014, and we've been searching for another one ever since. They're very hard to look for because this beautiful data on the screen takes like 2.5 hours at one of the biggest telescopes in the world. And those telescopes are very rare. The data and the time is very hard to come by. So we've been trying to put together other pictures of what a Thorne-Jitgov object might look like or how they form. And this actually takes me back to this little XKCD comic. This was actually from a little while back, where the author posted a goofy science comic talking about how we'd like to try making a Thorne-Jitgov object by throwing a neutron star at the sun and seeing if we can replace the sun's core with a neutron star. And maybe that'll make a Thorne-Jitgov object, which I'm sure would go great for everybody here on Earth. It was a goofy comic, but that is what one of my students is simulating. She's running numerical simulations of how a neutron star could impact a companion. And we've tried stars that aren't that unlike our sun. We've tried stars that are already red supergiants that are massive but still blue. And she's tried basically throwing a neutron star directly at it, sort of at a glancing blow to it, and looking at all the different ways that you could possibly do this, because it sounds like it couldn't possibly work. Other groups had tried to simulate this and failed. She actually has successfully simulated the formation of a Thorne-Jitgov object. Earlier this week, we were talking about putting the finishing touches on her research paper that she's getting ready to resubmit to a journal. We got some really useful comments back from a reviewer, and it's solidified even more what's in the paper. So we're really excited to finally start sharing this. But now that we know how you can make them, you can start to figure out how common they should be, where you might be able to look for them, and it'll hopefully help us with a more productive search from here on out.
Wow, we caught you at an exciting time. I'm glad we asked you
Great
that one.
timing. Yeah.
Yeah. Thanks, Bill. Great question and a great
Yeah.
answer. I hope someone's telling Randall Munroe about that too, the guy who writes XKCD.
I emailed him.
Oh, good.
He and I know each other a little bit. I got the chance to interview him for when one of his books had come out, and he's aware of Thorne-Jitgov objects and seems to like them a bit. So every once in a while, they show up in a comic.
Yeah, awesome. Yeah, everyone buy the What If series, by the way. Those are great books. But
Yes.
all right, cool. Let's do a couple more questions here. So John Pinto sent me one. Are there any possibility of detecting gravitons using gravity wave detectors?
Ooh. So gravitational waves are these sound like they should all be the same thing. Gravitational waves are a phenomenon caused by gravity. It's really funny because they were actually predicted by Einstein as part of his theory of general relativity more than a century ago. And at the time, Einstein sort of wrote them off saying, that sounds cool, but there's no way you could ever detect them. So, and then turned out they came back. But they're a consequence of his theory of how gravity and space and time interact. Gravitons, if I'm remembering the term correctly, because we are terrible at naming things in astronomy, and we have about 4 things that begin with gravit and then end in one thing or another. But gravitons are the predicted, or the name for what it would be like if there was a gravity particle. If we can model the way gravity behaves as a particle, you can kind of think of it like a photon. A photon is the particle manifestation of how light works, and the graviton would be gravity's equivalent. I do not believe that gravitational wave detectors are designed to detect such a thing. You would have better luck at something closer to a particle accelerator, so something like CERN. I know that people at CERN think about such things. I do not know how they could detect one, if they could detect one, if modifications would need to be made. But it's a little bit different because you're kind of in the realm of particle physics and theoretical particle physics, as opposed to looking at what's happening to space-time. The two are related because they both get at this puzzle of how gravity works, but you study them in different ways.
Cool. And we got a couple of other questions about LIGO as well, so let's stay on that theme for a minute. Quick one from Luke Corwin. What did they do about that Raven?
I believe that in the case of the Raven, it was pretty simple because they improved basically the outgassing and the cooling lines, and you didn't get as much ice, and then the Ravens didn't want the drink anymore. There's a couple other good stories in the book about birds causing problems. And there's an infamous one from back in the 1960s when Roger Penzias and Arno Wilson were getting ready to detect, or they were in the lead up to detecting what they eventually learned was the cosmic microwave background. They were building a radio telescope and trying to make it as sensitive as humanly possible. And they kept getting this annoying little background hiss and going, well, why can't we make our radio detector as quiet as possible? What could that be? And a red herring for a while was that they thought it was being caused by pigeons pooping in the telescope. And everybody tells that story and says, haha, they thought it was pigeons, but it wasn't. Nobody talks about what happened to the pigeons. And there are kindly pictures of like they trapped the pigeons and they tried to relocate them. They were homing pigeons. They came back. So eventually they took care of the pigeons and cosmic microwave background was detected. So birds were harmed in that story, but fortunately not in the LIGO one.
Yep. I've had birds mess up my weather detector on my own observatory in ways I won't get into right now, but yes, have a love-hate relationship. Alexander Happel asks, in what way has LIGO advanced our understanding of the formation, evolution, and death of massive stars?
Oh, this is a great question. It's transformed it in some ways because one of the cool things that LIGO detected in 2017 was it detected 2 neutron stars colliding. And this was a sort of end stage for binary massive stars that we thought should exist, but we didn't have very clear evidence of it yet. When two neutron stars collide, they released a little blast of gamma rays that we were good at detecting, but detecting the gamma rays and the other light from the collision and the gravitational waves all together, it immediately helped us start to figure out, how big can neutron stars get? How many of these LIGO detect gives us a picture of how many stars are in binaries like that. Those actually wind up directly relating to Thorne-Tittkov objects because I described two stars in a binary where one dies as a neutron star and it collides with the other star while that star is still alive. That means that that binary won't ever become two neutron stars that collide later. So when I write grant proposals and when I talk to colleagues, I tell them we need to understand how common Thorne-Tittkov objects are if we want to understand how common these gravitational wave sources are. We're not seeing as many of these colliding neutron stars as we thought. It could be that more of those systems than we think are becoming TZOs.
Very cool. And we're at the top of the hour now, so I'm going to give you a chance to skedaddle if you have to. We do have a few more questions, though, if you have time.
I can stick around for a few more questions. Absolutely.
Appreciate it. Thanks so much. Yeah, so Alexander also asks, how do you think remote observing has affected the culture and community of astronomy? And do you think future generations of astronomers will lose something by not experiencing observatories in person?
Oh, thank you for asking this. This also gets back at my title of The Last Stargazers because it's meant to be a little bit of a challenge too. We don't want to be the last generation of stargazers. I talked already about how scary things are looking funding wise, which obviously happened after the book came out. The book also came out. I finished writing the book shortly before COVID, and it came out during COVID. And in that period of time, we moved to a huge amount of remote observing. So it was even starker to see how the way that we work as stargazers changed. Remote observing is great in some ways. It makes astronomy very accessible. It makes it easy to observe in Chile one night and then in Arizona another night. I had that experience as even earlier in the era when I was writing the book. And I think that there's ways in which remote observing is lovely. I do have colleagues talking about how we learn less about telescopes by not physically being at them. There is something that is lost when you're not able to walk out the door and go, well, it's cloudy over there, but it's clear over there. Let's point over there. It's just harder when you're, text messaging an operator asking what's going on. And for young people training as astronomers, they sometimes lose the ability to do hands-on work. On the other hand, sometimes it makes it easier to just log into a telescope remotely and do hands-on work. The students I'm teaching right now that I taught in class today, half of them were missing from class because they all messaged me and said, we were observing last night. We were awake until 4 a.m. and they were observing on a telescope in New Mexico, but they were able to do it from our department. So they got experience that they wouldn't have normally gotten because you can't usually fly a class to New Mexico. So it's a mixed bag. I do think people really miss observing in person. I talk to a lot of astronomers that love remote observing and love all the technology that we have now, but they got such a smile on their face when they talked about shivering and prime focus on a cold night, but getting to see the most beautiful sky you've ever seen and take data. So it's good for science in some ways. It is too bad for the human stories of how we do science.
Mm-hmm. Yep. And, a related question from Bill Castro. Do you ever get a chance to look through an eyepiece these days?
Yes. Every once in a while, I actually tell a story in the book about being at a big professional telescope on an evening where there happened to be a few astronomers with time on our hands. And we put an eyepiece on the telescope and everybody transformed into a 6-year-old and was just like, oh, it's so cool. Like it never stops being cool. Not as much as I would like to, especially not in Seattle, but it is always beautiful to just look at it with your eyes.
Yeah, totally. My bucket list includes renting time on the 100-inch on Mount Wilson because they let you do that. You can look through the dang thing. It's crazy.
Oh yeah.
Yeah.
There's a great question in the chat from Lincoln, who's 10 years
Yeah, I
old.
wanted to get to that. Yeah, totally.
Yes. So this was asking about Thorne-Tittkov objects, saying instead of a neutron star, could there be a black hole inside? There absolutely could be. So the reason Thorne-Tittkov objects are named that is because they were come up with by Kip Thorne and Anna Zhitkov back in the 1970s. And we've kind of been talking about Kip Thorne without talking about him because he was one of the guys that won a Nobel Prize for studying gravitational waves. He's just a brilliant theoretical physicist. And when he was imagining Thorne-Tittkov objects, he was imagining a black hole or a neutron star inside what looks from the outside like a star. He had this whole idea that the gravity of the black hole or of the neutron star was actually enough to sustain an entire big layer of star on top of it. Outside, it looks like a normal star, but inside, you could have a black hole. We mainly focus on looking for the neutron star ones because they're easier to find. That neutron star makes the inside of the star really hot in really unusual ways, and that's how you make things like molybdenum. A black hole wouldn't do that, so we don't know how to search for one yet. We couldn't look for the little chemical signature that is normally the telltale sign, but we would love to try. And we're playing with other ways to look for Thorndyke objects that maybe would make it possible to look for ones with a black hole inside. So that's a great question.
Yeah, awesome question, Lincoln. Thank you so much. It's incredible. One more from Alexi. I wonder how red giants that survive the supernova blast are different from normal red giants.
That's a great question. So the idea is that you've got a red supergiant and then a companion that dies as a supernova, and then this guy's still around, and what happened to him? So we've killed a lot of red supergiants. In my student Lauren has murdered many a red supergiant in her simulation because you can throw the neutron star at it too hard, or it can eventually just get all its outer layers peeled off. There is actually a whole really interesting field in astronomy of what happens to the companions of things that went supernova. Even if it is not hit by a neutron star or hit by anything, it's usually getting sort of, they call it polluted by the stuff that got blown off of the supernova. Supernovae are great particle accelerators. They're great ways of making heavy elements. You might have seen a headline at some point of a supernova that was really good at making gold. It was actually able to create a lot of the heavier elements on the periodic table. So if you imagine a supernova going off and just blasting tiny amounts of gold out into space, that's cool. If it's got a neighboring star and a little bit of that gold falls onto the star, you now have a star with a little extra gold. It's, again, really hard to measure this, but there's people that have studied companion stars to supernovae and picked up the pollutants of the supernova explosion itself. And one of the things that we try to be very careful to do is tell the difference between that star has extra molybdenum because it actually has a neutron star inside versus that star is chemically weird because it rained supernova products onto it at some point. So it's a subtle but really important difference.
Awesome. Thank you so much for your time tonight, Emily. This has been awesome and great to hear about your latest research. And y'all don't forget to check out the book too, The Last Stargazers. It's a great read and highly recommend it. So thanks so much for your time and it's been great.
Yeah, no, thanks so much for inviting me. I'm unfortunately going to have to sign off at this point, but it was great to get the chance to talk to everybody. And thanks for all the great questions.
All right, it's been an honor. Thanks so much.
Okay,
Great.
bye.
Bye. All right, let me get back to the slide deck here and see if I can figure out how Zoom works again. Where'd Zoom go? Okay, share. Screen two. There we go. Yeah, so let's shift gears into club news here, and after that, we'll do our astrophotography showcase. So, what's going on in CFAS? Quite a bit. We still have some more dark sky nights scheduled out of Geneva. So, as we get more close to summertime, the weather's going to get a little bit more dicey. It's already getting dicey. In fact, it was supposed to be clear tonight, but I see nothing but clouds outside my window right now. But hopefully, we'll get lucky on one of these dates, May 23rd to 24th, May 30th to 31st, and maybe even June 27th to 28th. Actually, the 28th is our next in-person meeting, so scratch the 28th. It's 27th on that one. But yeah, weather permitting, keep an eye on groups.io for last-minute announcements on whether or not we'll be opening the gates at the Geneva site. And if you are new to the club, by the way, that's like halfway out toward the East Coast, basically from Seminole State College. And yeah, it's just a dark-ish place where we all gather and set up our telescopes and collect some good photons and talk shop. And it's a good place to actually learn about astronomy from each other. So if you got some questions about using your new telescope or whatever it is, that's a great setting for talking to fellow members and learning from each other. Also, thank you to everyone who supported the Orlando Museum of Art exhibit last month. That was a great success, and we got some really good publicity from that as well. So thanks to all the artists who supported that, to all the volunteers who came by and donated their time with outreach and showing people the views through the telescopes. Reached a lot of people there, and that was a lot of fun. So great success. By the way, if you were an exhibitor, we do plan on having your pieces at the June 28th in-person meeting, so we'll have those available for pickup there. Had a little bit of a snafu at the end of the event there, where we thought we'd have time to distribute those, but they kind of kicked us out rather abruptly because they had to set up for a wedding the next day. So a little bit of confusion there. But your stuff is safe. It's in storage, so don't worry. You can collect those on the 28th. Also, we're still working on remote C-star access. We're getting closer to that thanks to our awesome Lunar Telescope chair, Christopher Hunt. And we were just working out the final kinks. So the idea there is that we're going to ship off a C Star to a remote site in Texas and let people sign up for time on it and access it remotely. So this could be the future of the loaner program. Stay tuned for more details on that once we get things worked out. But yeah, we're just down to like one or two issues before we ship that out. So still in the works. Also, watch out for the 2025 member survey coming out soon. We're going to be sending out another little Google Forms link there to let you know or let us know what you want this club to be up to and what you want to see more of, what you want us to do less of, kind of get your voice in there. We have a lot of new members this year, so we want to hear from you as to what you want to get out of this organization. So keep an eye on your email for that. Upcoming outreach opportunities, things are starting to wind down with summer coming up, but tomorrow night, Redbug Elementary is up next, and the night after that, the Alliance Francaise event being led by our own events chair, Isabel. So sign up for that too if you're interested in supporting that as well. And we have another Orlando Science Center Science Night Live. Why is that hard to say? On May 31st. If you're interested in supporting this, and if you're new to the club again, outreach is basically taking your telescope out to the public and sharing the views with people. And it can be a very rewarding experience. If you're interested in participating, head on over to the outreach subgroup on cfas.groups.io with this link here, or just email outreach@cfas.org to contact our outreach chair, Douglas Woods. And I mentioned this before, but our next in-person meeting will be on June 28th at the planetarium. Our main speaker will be Derek Demeter, presenting in the Planetarium Dome a couple of programs. First of all, Astronomy Down Under, with some of his adventures from the Southern Hemisphere, and also what he took back from his recent excursion out to Italy, where he did some educational work out there for some Italian school kids. And he also got to see some pretty cool stuff out there from Galileo and whatnot. So we'll have a little bit of show and tell of astronomy in Italy out there. And as always, we'll have breakout rooms for special interests. TBD, if you're interested in leading one, by the way, do let me know, president@cfas.org. Also, some exciting news. We have officially been recognized as having the best astronomical club website in the world. So the Astronomical League has issued an award to Rob Fleming, who designed our current website at cfas.org. He is going to be the winner of the 2025 Webmaster Award from the Astronomical League. So congratulations, Rob, and thank you so much for all the work you've done for making our website look awesome. This is kind of the face of CFAS for a lot of people, and it's been a very important force for our growth. So can't thank you enough, Rob, and very well deserved. I get contacted from presidents of other astronomy clubs pretty frequently asking who did our website. So they want to learn from us, and that's a great thing. The more we can spread these best practices around other astronomy clubs, the more impact we'll have collectively. So congratulations, Rob. Really, thank you so much. Also, new members, welcome. Thank you. There's a lot of you. We had like a huge influx early in the year, and they're still coming in. If you are new to the organization, be sure to read your Welcome to Central Florida Astronomical Society letter that came with your membership. If you didn't get that, let me know. We can resend that to you for sure. But that'll walk you through how to access our community platform on Groups.io, which is kind of the main hub of information for this organization, and explains your other member benefits as well. And if you have any questions, that's what our board members at large are for. So Wes Clem or John Pinto can be reached at bmail1 or bmail2@cfas.org if you have any questions or concerns that you want to filter through to the board of directors. Or feel free to just contact me directly if you're comfortable doing so. That's cool too. Speaking of the board, we need your help. Unfortunately, Christopher is going to be stepping down as our loaner program chair. His day job is turning into a night job, I'm afraid, and conflicting with CFAS. So if you have been a beneficiary of the loaner program and you want to step up and give back, please consider serving in that capacity. Honestly, I think we're going to need 2 or 3 people to fill his shoes. So if you're interested in being involved in sort of maintaining our telescope collection and making sure everything's all ship shape in our storage unit and getting people set up with their loaners and collecting those back, please consider helping out. You can reach me at president@cfas.org or just talk to Christopher and talk to him directly about what's involved. We need help. We also have a couple of other openings on the board for publicity and education. So if you're interested in like social media or anything like that, or also in just developing more educational programs and content for the club, do contact me. We're always looking for fresh voices and fresh ideas. You can also just serve on a committee if you don't want to be a committee chair. So you can sort of get your feet wet by just serving on any of our existing committees on the board and kind of learning as you go. And be the kind of the Padawan learner there. Existing committees include events, programs, outreach, treasurer, science, website, membership, observing, or you can make up your own. If you got an idea of what you want this club to be doing, let's hear it by all means. So yes, please consider getting involved. We're all volunteers here, and this club needs all the help we can get. Speaking of help, don't forget that we do accept tax-deductible donations if you're so inclined, and if you're in an organization that does matching, even better. We are a 501c3 organization, so anything you donate is tax-deductible. And like I said before, we're volunteer-driven, so every penny just goes toward the club and not to anyone's pocket. So we are seeking sponsorships as well and corporate donations. Please contact John Frank at treasurer@cfas.org if you know of a company who might, want to be giving away some money to a good cause. We'd love to help them with that problem. We're also in Cyber Grants, which is the platform used by Disney and some other employers. So if you happen to be a Disney cast member, any donations you make will be matched by Disney as well through Cyber Grants. Upcoming astronomical events. We are still firmly in galaxy season, although in the morning time we're starting to see the summer Milky Way rise. But, assuming you're not too much of a night owl or too much of an early bird, most of the targets you're going to be seeing right now are going to be galaxies outside the plane of the galaxy, of our galaxy, or maybe some globular clusters as well that are sitting outside the main plane of the Milky Way. It's just, the way the Earth is pointing this time of year. So right now, the Milky Way itself is where all the nebulas and stuff within our own galaxy live. Those are pretty low in the sky right now. So we're looking outside of our galaxy at this time of the year to distant galaxies, which are even, well, I won't say they're more cool than nebulas, but they're pretty darn cool. These things are tens to hundreds of millions of light years away, which is incredibly distant. And a galaxy like this one is, you're looking at hundreds of billions of stars there. And it's just fun to imagine what might be in there. The sheer number of worlds in that galaxy looking back at you makes you wonder. But closer to home within our own solar system, on May 22nd and 23rd, watch for the moon and Saturn being close by. Also, Venus will be in kind of like a triangle with it in the morning time. This isn't really a great time for observing planets at night, but in the early morning, they start to be more visible. So if you do get up early, watch for that toward the end of the month. And at the very end of the month on May 31st, the moon and Mars will be within 4 degrees of each other. So look out for that. If you see a little red dot next to the moon, that's what it is. And then on June 1st, Moon and the star Regulus and Mars will be together as well. So a lot of cool, fun conjunctions coming up. And then Mars and Saturn will be reunited on June 19th, being nearby as well. So cool. And as we get further in the year, these things will be getting more and more toward the beginning of the evening and easier to observe. Saturn, by the way, I didn't put this on the slide, but it's at a very interesting point right now. If you do get up early and you're able to observe it, the rings are pretty much edge on with us right now. You can't see them. It just looks like Saturn doesn't have its rings anymore. So kind of a unique thing that you probably won't see again in your lifetime if you have a chance to observe that. But Saturn without its rings, well, I guess that's probably how it started, right? People don't think those rings are actually that old. And with that, let's move into our astrophotography and sketching showcase. As always, if you're present for this, I will unmute you or invite you to unmute yourself, rather, and talk about what we are looking at here. Let's start with our own Luke Skywalker. And I know that you actually are on a platform, you're watching on a TV, so you can't actually talk back, but you did give me some notes about what we're looking at here. So this is a C-star image from a C-star S50 in equatorial mode captured at Geneva from our dark sky location on April 25th. 2 hours and 10 minutes of exposure time. That's a lot of data. And no filters and a little bit of processing in Fireworks CS5. And Luke asked for more Geneva if possible, please. Yes, your wishes are command, as we just talked about. So we do have 5 more dates lined up, weather permitting. So keep an eye out on Groups.io for details when that time comes. Peter Lefebvre, also an M51. He says he's out traveling this week and won't be able to attend, given the time zone, but he wanted to contribute this as well. He says he captured M51 using the C-star S50 while searching for the lunar X and V, foreshadowing, we're going to see that soon. That was successful thanks to some guidance from other CFAS members as well. So he's experienced a lot of gradients in previous sessions. So he made a crude shield to stop stray lighting hitting the lens and went to 10-second exposures to see if it made a difference. He says he applied some of the learnings working on Quinton's NGC 2903 raw data for the post-processing. This was taken on May 4th in West Kissimmee, 542 subs at 10 seconds each, stacked using the C-star script in Serial, and he used Graxpert for gradient removal and denoising, and another round of color calibration and stretching in Serial as well. So thank you so much. John Pinto, I think you're here if you want to take the mic. Got some good sea star images here.
Yep. Hi, Frank.
Hey.
Okay, so we will start with the sun. This was a few days ago when we had that huge sunspot right in the center, active region 4079. And just for a sense of distance, because we're going to be talking about a few things, I think, the sun, if you don't remember, is 8 light minutes away from us. Okay, this is the Silver Needle Galaxy.
Okay.
I had done all of the Messier objects, and I said, well, what am I going to do next? So I said, let me start on some of the Caldwell objects. This is Caldwell number 26. And if you don't know what the Caldwell objects are, Patrick Moore, who was actually a very good friend of CFAS back in the 80s and the 90s, he actually visited us a few times. Sir Patrick Moore was a very famous British astronomer, did a lot of popular astronomy books. A lot of people got into astronomy or learned astronomy through Patrick Moore. Anyway, he was tasked by Sky and Telescope magazine, I think, or it could have been a British equivalent, to what should people observe after they've done all the Messier objects. So he claims that he sat down one evening after he got this letter, because this is back in the day when people sent letters, and he said, oh, I'm going to scribble down, I don't know, my top 100 objects that are not Messier objects. Now, it turns out that some of them are not that interesting to observe. They just happen to be interesting to him. But this one definitely was one that I thought was pretty amazing. So I definitely wanted to take a capture of it. And it's in Canis Venatici. It is 14 million light years away. And it's pretty easy to find, especially if you've got a sea star. It's pretty easy to capture.
Yeah, I was like trying to remember what 4244's common name was. So that's the silver sliver you said, right?
Silver Needle.
Silver needle. Okay, there's so many like edge-on galaxies out there
I
with
know,
similar
I know.
names. Yeah, cool. And did I hear you right? You've actually done every Messier object at this point?
Yeah. I mean, through the couple of years that I've had the sea star, yeah.
Wow, that's a testament to, how efficient sea star observing can be. That's cool.
Yeah, and it's not like I did like long exposures, right? So I made sure that I could actually observe the object, recognize it, right? So typically there were 10 or 15-minute observations.
All right. Yeah, no cheating. Good. Speaking of globular clusters, NGC 5139.
Yes, which also is a Caldwell object. That's Caldwell object number 80. As you said, the Omega Centauri. It is 17,000 light years away, so it's not millions of light years away. If you want to see this naked eye, supposedly you can actually observe this. It's, I think, magnitude 4, but you're definitely going to want a dark sky. The way you find it, at least for me, the way I find it, because I use my binoculars to find it a lot of times, is I'll wait till Spica is pretty much due south, which right now is around 11:15, 11:20 in the evening, and then just look directly below it. And you will see this fuzzy, large ball in the sky. It's about 15 degrees above the horizon, so that's the other way you can sort of see it. But anyway, it's a great thing to look at. As Frankie, I think you've mentioned before, this good speculation. This is not just your everyday average globular cluster. This may actually be the heart of a galaxy that the Milky Way ate, devoured, and this is kind of the leftover core of that galaxy. It's the largest globular cluster. It is 150 light years wide, and it's supposedly has about 10 million stars in it.
Mm-hmm. I think I read some speculation there might even be a black hole in there, but I'm not sure what the
that's possible too. Yep.
Yeah. And you took this at Geneva, right?
Yep. Both the Silver Needle and Omega was from our Geneva nights in April.
Yeah, and not only is that a darker place, but you also have a pretty clear view of the horizon there too, which is important for Omega Centauri because it's pretty low in the sky.
Yeah, I think when you and I were talking, once you had actually chopped down your palm tree to actually see it.
Yes. Yeah, actually, yeah, there's a very pesky bush to the south of Domi McDome face that got a haircut today for that reason. So it's blocking my view of Omega Centauri. The yeah, the landscaper's got a kick out of that.
The
Very
other thing,
cool.
oh, sorry, there's one thing to just note about this. Everybody's been talking about the S50 C
Mm,
star. This was the S30 C star. So this is only a 30 millimeter refractor. And
yeah,
it's just amazing you can get this kind of thing.
absolutely. Yeah, I mean, globs are cool targets, in and of themselves. They're pretty bright, right? So even if there's a
Yep,
bright moon out like there is tonight, these still make for good targets, and they don't take a ton of exposure time. So they're always fun ones to image.
yep.
And another M51.
Yes, this is my M51 again from Geneva that same night everybody else was taking it. And basically, this was my uh, test shot, let's call it that, before I did the silver needle. I wanted to
Mhm.
just make sure things were working. And I said, well, what's a good target? And they said, oh, M51 is nice and high in the sky. Let's give it 20 minutes. And it came out great.
Yeah, that's definitely one of my favorite galaxies, or more technically pairs of galaxies. That's
Yeah, that's
that.
true. The companion is NGC 5195, in
Hmm.
case anybody wants to know. That's also in Canis Venatici, and it is 31 million light years away. So it's further away than the Silver Needle.
Hmm. Yep. Very fun target though. Yeah, the more time you give this target, the better it looks too.
Oh,
Like it
yeah.
just
Oh,
it
yeah.
just never stops getting better. So,
Exactly.
and our nearest neighbor.
Yes, this is our 1.5 light second away neighbor.
Mhm.
This was this morning, actually, 2 days past full. It just looks so beautiful in the sky. I just had to take my S30 out again. That's the beauty of this S30. You can basically have it in its case, see something in the sky, for me, stick it out my back window.
Mhm.
That's through a window. And in 4 minutes, you're taking these images. It's just amazing.
Wow. Yeah, that came out great. That's through a window. My gosh, that's so cool. Thanks so much, John. Great stuff as always. And again, a reminder, John is our board member at large and also our Astronomical League coordinator. So if you have any questions about the Astronomical League observing programs, do drop him a note. Are you BMAL 1 or BMAL 2? I always forget.
I'm two, I think.
All right, BMAL 2 at cfas.org to get in touch with John.
Thanks, Frank.
Thanks. Luke Corwin, I think you're on still. Speaking of the Lunar X and V, you
Yes.
actually captured it.
Yes, I did. Um, and I guess I'm Luke Skywalker too then, and I should I should point out I was actually named after him.
Oh my
So
gosh, you
that's a
win.
fun. I'm trying not to be competitive, but I don't run into I just don't run into too many other Lukes. So there we go. Anyway, so I didn't actually set out to capture anything when I was observing on this night. I just took my telescope out to look at the moon for fun, and then I noticed, hey, that kind of looks like an X. And then something connected in my brain, and I went, wait a minute. And I realized I remember this was something that's only visible for a few hours every lunar cycle. So I put this contraption together where basically this is a picture taken in the evening of May 4th uh, through with a Nikon D5000, and I have an adapter for my telescope that allows me to take pictures through an eyepiece. So this is a camera through an 18 millimeter Agena 1.25 inch Stargazer dual ED eyepiece through a Celestron Edge HD 800. And all of that gets you this picture, which is a little bit wobbly because I haven't used this very much, and it was really humid. So I took several images. This was the best one, but I'm hoping to go back to my notes and any material we have from that Shoot the Moon workshop we did a
Hmm.
few months ago to see if I can clean this up a bit. But
Yeah.
that's the Lunar X, and then I also took a picture of the Lunar V.
Mhm.
And both of these are 1/5 of a second exposures at ISO 3200. So that's a pretty high ISO. It's an older camera. That's why you've got some of the red hot pixels, but you can still see the V. And this was just really a happy coincidence. And I'm glad I had a chance to take a picture or
Yeah,
two
that's a
pictures.
great. That's an amazing stroke of luck, actually. Like,
Yeah.
people plan this all month to be in just the right place and right time to capture this, and you just happen to stumble across it. So
Yeah. It was
well played. Oh, I think we lost you, but thank you, Luke. I'll wrap up with a few of my own. These are all from a couple of months ago, actually, but I don't think I've shared them yet before. Past month's been a little bit crazy here, but I'm hoping to get some time back on Scopy McScopeface soon here. This is M88, Messier 88 within the constellation Coma Berenices. And this is actually part of the Virgo cluster of galaxies nearby. And by nearby, I mean 50 to 60 million light years away. These are incredibly distant, actually. And I just love these sort of deeper field images because if you look in the background, I'm not sure if it's coming through on Zoom or not, but there's just a ton of other galaxies surrounding it in this part of the sky. It's just like filthy with galaxies. And you can certainly see a few of them. There's M88 in the corner there, but also a few other, less defined ones here, more elliptical there, and sort of an irregular, maybe a dwarf companion over there. I'm not sure what the deal is with that, but I just love sort of exploring these images for what's in the background. And if you look closely, you can see a lot of those stars aren't stars at all. They're other galaxies. It just kind of blows your mind. So I love that stuff. Again, we're in galaxy season, so that's what I'm focusing on right now. This is the Needle Galaxy, NGC 4565, again, with some friends. So if you look in the background, there's tons of other ones that are even more distant. This one's about 40 million light years away within the constellation Coma Berenices. And again, just, if you zoom in and like look around in this image, there's just so much to explore there, which is a ton of fun. This one is NGC 4395. This is what they call a low surface brightness spiral galaxy, only about 14 million light years away from Earth, also in Canis Venatici. I'm probably not saying that right, but you get the idea. This is kind of interesting because it has an active nucleus, and this is classified as a Seyfert Type 1, known for a very low mass supermassive black hole in there. Normally a more diffuse galaxy like this, you wouldn't expect something like that, but yeah, they think there's a black hole in the middle of this thing. So pretty cool stuff. And I think that wraps it up. So again, thanks everyone for joining us here tonight. And it was a great meeting. Really, thanks again to Emily Levesque for joining us tonight and sharing her stories. And, do check out her book. It's quite good. So really enjoyed that. And thanks for everybody who contributed to the Astrophotography Showcase. Again, we'll be seeing you on June 28th for our next in-person meeting. So watch for more details on that and maybe even sooner at Geneva. So thanks everyone. Keep looking up. Take care.